So, how does an AI actually learn to predict a specific number, like the price of a house or what the temperature will be tomorrow? It sounds super complex, right? But believe it or not, it all comes down to a simple skill that you and I use every single day.
Just think about it for a second. You do this constantly, probably without even realizing it. You see a bunch of dark clouds rolling in, and you guess it's going to rain. You walk past a restaurant and see a huge line out the door. You figure the food must be pretty amazing. At the end of the day, all you're doing is using patterns to guess what's going to happen.
And this very simple idea, guessing with patterns, well, that's our starting point. It's the exact same intuition that AI has learned to copy and then just amplify on a massive, massive scale.
I mean, think about the kind of questions we ask all the time. If I put in more hours studying, will I get a better score on my test? If a house is bigger, is it going to cost more? It seems like there's a connection there, doesn't it? Well, that intuitive link is exactly what we're going to unpack.
Now, in the world of AI and data science, this whole process of predicting a number based on a pattern, it has a special name. And that name is regression. Yep, that's it. It's really that simple. So from now on, whenever you hear the term regression, I just want you to think predicting a number. We're not talking about a category or a simple yes or no answer, but a specific, concrete number. And the kinds of numbers it can predict, well, they're literally all around us. What's the price of a stock going to be next week? What's the temperature going to be tomorrow at noon? How many sales are we going to make next quarter? If the answer you're looking for is a number, you're almost certainly dealing with a regression problem. Okay, so how does the AI actually pull this off? How does it go from just seeing a bunch of patterns to spitting out a specific number? The key is this really cool and powerful visual idea, the best fit line. Let's use a super simple example to see how this works. Here, we've got some data tracking study hours against exam marks. The pattern is pretty obvious, isn't it? The more hours you study, the higher your marks. This is exactly the kind of raw info we would feed into an AI. Now, imagine we take each of those pairs of numbers, 1 hour and 40 marks, 2 hours and 50 marks, and so on, and we just put them as little dots on a graph. You'd pretty quickly start to see the pattern visually, right? A clear trend going upwards. And this is where the best fit line comes in. The AI's whole job is to draw one single straight line that gets as close as it possibly can to all of those dots. That line is the pattern. And once the AI has that line, it can predict a score for any number of study hours, even for numbers it's never seen before. Now, the real trick, of course, is making sure the pattern is a real relationship and not just some random coincidence. Now, this next point is absolutely crucial. Regression is all about predicting numbers, and that makes it totally different from the other major type of AI prediction, which is all about predicting categories. And this slide just nails the difference. Regression answers the question, how much or how many? It'll tell you the temperature will be, say, 24 degrees. On the other hand, its counterpart, classification, just puts things into boxes. It answers which one. It would predict yes, it will rain, or no, it won't. See the difference? One gives you a number, the other gives you a label. Okay, I know this might sound a little bit nerdy, but understanding this difference is huge because the real-world impact of regression is absolutely massive. It's truly one of the quiet workhorses of our modern economy. Seriously, just think about it. When an app predicts your home's value, or a company forecasts stock prices, or even when a doctor tries to estimate a patient's response to a certain medicine, that's all powered by regression. These models are running everywhere all the time, making incredibly high-stakes predictions every single second. And really, that's the bottom line. This isn't just about predicting things for fun. It's all about using those predictions to make better, smarter, more informed, data-driven decisions. It's about taking some of the uncertainty out of a very, very complex world. And you better believe this field is not standing still. The way AI does all this prediction is constantly evolving, getting more powerful and way more sophisticated. We're seeing some amazing new trends, like AutoML, where the AI itself actually figures out the best way to find the patterns. And with big data, these models can now find these incredibly tiny, subtle patterns in data sets so gigantic that no human could ever possibly analyze them. The predictions are just getting better and better. So to bring this all home, let's just circle right back to our simple core definition. What is regression? It's just a method for teaching a machine to find patterns in data so it can predict a number. It's the tool that AI uses to answer those fundamental questions, how much and how many. And that leaves us with a pretty fascinating thought to end on. For decades, we've been building these incredible machines to answer questions of quantity. Now that they're getting ridiculously good at it, maybe the most important question isn't for the AI, but for us. What should we be asking it to predict next?